Now, Lecture 5. We will learn central tendency, measures of central tendency and skewness in this lecture. And the objectives are uh, measures of central tendency. We will learn the mean, weighted mean, and median, mode, and the mid-range of data. And also, we will discuss the shapes of the distributions and skewness issue. Now, first, let's start with a recall. A parameter is a numerical measurement obtained by using the population data. So, for example, like population average, we call it mu, population standard deviation like sigma. So all these are parameters because they are coming from the population. And the same things, the same like average and standard deviation, if they come from the sample, we call them statistic. And we denote them by different symbols like X bar here, the sample average, and the standard sample standard deviation with S. And these samples are used to estimate the population parameter. So statistics is used to estimate the population parameter. In chapter 2, we discussed how to group the data using the frequency distributions, and we learned how to present the data by using the graphs. And now also we have to look at some other things as the central tendency of the data and variation of the data and the measures of position to display a set. So today we will do just measures of central tendency. Now the measures of central tendency are weighted mean. Okay, the first one is the mean, and then the median, mode, and the weighted mean and the mid-range. So we will learn how to calculate them. So the mean of a statistical data set is the sum of the values divided by the total number of the values. And here, yeah, we can write it as an equality here. The mean means the average. And if we are calculating the mean of a population, mean of a variable from a population, then you say this is, you use the symbol mu for it. And then for the sample, if you are dealing with a sample mean, that means like you're calculating the average of a variable coming from the sample. So it means you can use X bar. So there, I mean, the formula is same. I mean, indeed, the same. We use the same formula for all of them, but it depends on how your data is given to you. If it's a raw data, you basically add all the numbers, all the data values, divide by the number of the numbers, and you do the same here for the sample. It's same. But when it is grouped frequency distribution, then you will be given, your data will be given like the frequencies here, and then there's the classes here. So in this case, you have to find, by using the classes, you have to find the midpoints and multiply with the frequencies and divide by the total number of the frequencies. And for the ungrouped frequency distribution, you basically, if this is given to you, the frequency is given to you, and you have the x values here, and then you will multiply these values, like the value of the data times its frequency, you multiply them, then you add them, and then you divide by the number of the frequencies, and you use this formula. So it depends, okay, which formula to use depends on what is given to you. This is the main important thing. Now we'll get used to the formulas from the example. Now the mean of raw data um, from the sample or from the population, we have the same formula. All the raw data, the sum of all data divided by the number of data. So let's look at this question here. And data below are the marks of 10 students and quiz 1, find the mean. So this is raw data here. And if you want to find the mean of the raw data, you basically add all of them, divide by the number of data. So you add all these. So this makes 55 and divide by 10. 10 is the number of the numbers here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you write 10 here, so this is 5.5. What you can say here is that the average score of students in quiz 1 is equal to 5.5 because these are um, the marks in the quiz 1. Now let's look at this example. Now 10 people are playing golf at one hole. Their scores are these. So find a population mean. So the data is given to you. The mean, if this is a raw data, as you see here, since it's raw data, you add all the data values divided by the number of data values. You add all of them. Here we have the sum 51. And this is the number of the numbers here, number of the data values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here it's 10. It's also saying here 10 people. So it's 5.1. So the average score is equal to 5.1. Now, the mean of frequency distribution. Here, the frequency distributions can be given to you in two ways. Like one of them is grouped frequency distributions, and the other one is ungrouped frequency distributions. Now, for the grouped frequency distributions, you will use the midpoint here. So XM is here the midpoint. And I want to remind you what is grouped frequency. How do you know this is grouped frequency? Generally, this is classes given to you and the frequency given to you. So this makes grouped frequency. But here in the ungrouped frequency, there are the values, data values, and then frequencies, not the class here. So that when we say class, it's like 1 to 10, that 1 to 20, you know. But here you will see just numbers here, 3 maybe, 4 maybe, and then the frequencies like 2, 3, anyway. So these are the formulas we use to find the mean of grouped frequency. And here we need the midpoints. Okay, we will see how to use the formula in the examples. Now the mean of grouped frequency distribution. Now we find the midpoints and then we multiply the frequency for each midpoint or for each class. We add all the products and then divide by the number of the data value, the number of the frequencies, the total frequencies. So n is, you can write as n is the total frequencies, the number of data values in the sample, or it will be equal to the sum of the frequencies. Now let's look at this example. The following table gives the distribution of the circuits, the number of the circuits with respect to their cost of repair. So when you read this table, you will understand we have 10 circuits whose repair cost is between less than 19 reals. And the 20 circuits, we have 20 circuits in each. The repair of each will cost between 20 and 39. Now, this is here indeed, it is grouped data, as you see, grouped data. So this is, and this is for the frequencies, and this is for the classes here. So it's asking to find the mean. Okay, find the mean of the repair cost. Now, indeed, it's asking the average repair cost for a circuit. So now this is group data, so we have to use the mean formula for the group data. Now, first we construct the following table so that we have the class limits that are given to us, the frequencies are given to us. Now we have to use this formula for the mean, so it will be f the frequencies times the midpoints, their sum divided by the number of the frequencies. So the number of frequencies is 40, so we need to find this products here. So for this reason, we have to write the midpoint. So how can you find the midpoint of this class? So 0 plus 19 over 2, which is 9.5. So let me tell you here. We got this one, 0 plus 19 over 2 is 9.5. We can do it the rest the same way. Okay. And then we will calculate this products here. We multiply these two and we will get f times xm, and we will do the same thing for each of them. So it's 95, 590, and then 396. So each time we multiply and we will get this. And the sum, so you add all of them, here, you add this column, and you will get the sum. Here you got the numerator, and the denominator is 40. We can substitute them in the formula. So 1,240 divided by 40, which is 31 real. So it means per circuit, on average, one circuit costs 31 reals. And let's look at the mean of ungrouped frequency distribution. So in here, you have to multiply each x value with its frequency, and then you add all of them and divide by the number of n. So number n, which is the number of data values. Indeed, you can write this n as the sum of the frequencies, because the sum of the frequency will give us the number of the data values. Now let's look at this example. A grocer buys a food product from a wholesaler in lots of 100 boxes. 100 boxes. So the distribution of 20 lots purchased according to the number of outdate boxes was as follows. So this guy's he buys 20 lots in one lot. There are some boxes here. In each lot there are boxes, and in some, so from one lot you might have outdated boxes and good boxes. This outdated boxes are not good. So this table says in 9 lots we have 0 outdated box. In 4 lots, we have 1 outdated box, and in 3 we have 2 number of outdated box. So the question here is, in one lot, we have 100 of them, all outdated boxes. So we want to calculate the mean of the number of outdated boxes. So per lot, let's say per lot. Okay, so in this case we have to treat this one as the frequency here, and this is the value x. Now we have to use, this is an ungrouped data, so we have to use this formula of the mean. Let me write, this will be, the mean will be x bar is equal to f times xi divided by the sum of the frequencies. Now here are xi's, and these are the frequencies. Then you can add all of them. You will get the n, the value of the data values, the number of data values 20, and then you will multiply these xi times fi, so it will be 0, 4, 6, you multiply them, then again 6, again 4 times 1, and then 5 times 0, or 1 times 100. So this product here, this product, the sum will be equal to 120, and when you substitute also 20, you will see this one. So x bar will be 120 divided by 20 is 6. So we say the average number of outdated box per lot is 6. So in each lot, we have on average 6 outdated boxes. Now, what was the weighted mean? Sometimes in raw data, when you try to write the frequencies, you look at the repeated values. But in some cases, we do not have repeated data values, but we assign the weight for each value. So because some data elements will have more weight than the others, and not all of them are equally represented in some cases. Okay, it's not happening all the time. We will see in which case do we have weighted mean. So the weighted mean of a variable is obtained by multiplying each value of the variable with its corresponding weight, and then we sum these products and then divide the result by the sum of the weights. So you have some data values and you assign some weights for each. So you say this type of data x1 has the weight 1 and the x2 has weight 2. And it goes like this, and then you add these products, divide by the total of the weight. So this gives you the weighted mean. One of the well-known application of the weighted mean in our life, especially in the university, is the GPAs, the calculation of GPAs. Now, GPA is an example, is a good example of weighted mean. Now, the table below shows the credits in some courses and the grades received by Ibrahim in these courses. And it says find the grade point average of Ibrahim. So he got these. These are the credit hours for each course, and these are the grades he got, like 5, 5, 4, 4.5. These are corresponding to the letter grades like A plus, A plus, B plus, A plus, A plus. Now these are becoming, now we don't take it as a data, I mean, for the frequency, but we take them as the weight because the credit hours are now here, the weights, and the grades are X. The weight is determined by the number of hours, the credit hours. The more credit hours means the more weight a course has. So for example, the English is number one. You have to pay attention to English it contributes much to your GPA. And the second goes to math, and then maybe Arabic learning skills and computer skills. And the last one, the least weight, it belongs to the physical education. Now we use the formula. What is the formula? The formula is you multiply the weight with the values, and then you multiply them like 15 and then 25. You multiply them 2 times 4, 8, and then 1 times 1.5. Okay. And 2 times 5 and 2 times 5. And all these are written here, and you add all of them. And you divide, so you add these also, 3, 5, you know. So they're given here, so you write the weights, the sum of the weights, the sum of the products, you calculate, and the GPA of Ibrahim turns out to be 4.823. So So you can calculate your GPA, and GPA is important because you need you need to reach a GPA before the graduation. Even you pass all the courses, if you don't come to a certain GPA, you cannot graduate. Let's look at this question. A student scored 62 in test 1, 83 in test 2, and 91 in test 3, and 91 in the final exam, and 76 in homework. So test 1, test 2, test 3 is worth 20% of the final grade, and final exam is worth 25% of the final grade, and the homework is worth 15% of the final grade. So what is the student's final grade, or the weighted mean of scores in the class? Now, um, basically, it's asking the weighted mean of the scores, but let's write them here. Test 1, student score is what? Okay, let's write the scores here. Test 1, test 2, test 3, final exam, and the homework. And test 1 is 62, test 3 is 83, test 3 is 91, and the final exam is 91, and from the homework you got 76. And the weights of the scores in the final grade, it is 20%. So here you can say this is 0.2 means like 20%, which is 0.2, like 20 over 100. So then it's 0.2 again, it's 0.2 here, and final exam is 0.25 and 0.15 homework. Then the question is, how can we get the weighted mean? The weighted mean is you have to multiply these scores with the weights. So if you multiply it, it will be 124, so it will be 12.4, and this will be 16.6, and this will be 0.2, and this will be 22.75, and this will be it will be 3 times 38, so it has to be 3 times 3, 9. So 11.4. Now the weighted mean can be calculated. Okay, we know it's equal to the weight times the scores divided by the total of the weights. Now we have to calculate this. These products here is your X score, the weight here W. So the XW's are here. So when you add them, you will add all these. All these scores are getting us. Okay, let's see. The first two will be 29. This will be 29, and these two will get us 40.95, and with this 11 plus 4, 11.4, so 20, it will be 40 here, 81.35, so it will be 81.35. And when you add all the weights here, so all the weights, they come to 1, they make 1. So the weighted average, or so weighted mean of scores, or the student's final grade will be 81 over 81.35. So this is 1, so it doesn't affect the result. This 81.35. Now mode is the value that appears most often in the data set. So most often appears, or you can say most repeated value. You can also say it's most repeated value of the data. Now we have we might have one mode, no modes, two modes, or more than two modes. In each case, okay, if we say there's no mode in the distribution, it means the distribution has no mode. So if it's a one mode, it has a one mode, and then we call it the distribution is unimodal. And if a distribution has two modes, we call it bimodal. And if we have more than two modes, it will be a multimodal distribution. So here is, like, for example, 1, 2, 2, 3. 2 is most repeated, so there's the mode is 2. But sometimes it happens that there's no mode here. Okay, nothing is repeated more than 2, so no mode. And here, this is, let's say, 1, 2, 2, 3, 3, 4. So you see the modes are, we have two modes, 2 and 3. And we can give an example with more than two modes also. Okay, let's look at this example here. On a group of 10 people, you ask everyone how much money they have, and here is the result. And it says find the mode. To get the mode, the first thing you have to do is you have to arrange the data. So arrange the data in order, so it means right from the smallest to the largest. So 5, 5, 10, 10, 10, 10. So we have 4 tens, 15, 15, then 20, and 500. So we write all of them, and then we check here. The most repeated value is 10. So the most repeated value is 10. So the mode will be, the mode of the data is 10. So this distribution, or this data, is unimodal. So because it has only one mode, unimodal because it has only one mode. Now let's look at this example. The following table gives the scores obtained in statistics by a group of students. Now here are the scores and here are the frequencies. So it means if you write it in raw data, there's 1 6, there are 2 8s, there are 8 10s, that means 6 12s, 2 14s, and 1 18. So which one is the most repeated one? Of course, this 10. And here you can check it from the frequency. So you know the frequency gives you how many times it's repeated in the data. So the mode will be 10. Now let's look at this example. Again, we have a table here, and in this table, this gives the 10, the distribution of 100 companies according to their annual turnover in thousands in Saudi riyals. Now we have 18 companies in this range. Okay, I mean in this interval, having annual turnover between these two values. and 15 companies between this interval, between these numbers. So it's asking find the mode. Um, this question is a little different because we have a group data here. This is group data, and we have a different procedure here to find the mode. First, you find the model class. The model class is the class that has the most frequency. So this here is called the model class. So it will be the model class. So after you find the model class, you will find its midpoint. So the midpoint of the model class is the mode. So it will be 300. So let's look at this example. A survey was conducted to assess the proportion of items that the customer wanted to find in store. So these are the found items and the frequencies. So two customers says, I didn't find any of them and nothing. 6 customers said, I found some of the things I wanted. And 9 of them says, like, I almost find all I need. And the 3 of the customers says, I found all of them, all I want. So here, what's the mode of this distribution? So as you see, the variable here is not numbers here, so it might be categorical variable, but still we have a mode here because the answer, the most repeated answer, the almost all, is our mode. So median, so we have median. The median is the value that divides an arranged data. Here the arranged data is an important point here, because we are talking about an arranged data. Arranged means the in order. So then the median is just the value that separates or that divides the data into two groups, into two equal parts. Now the median will be one of the data values if there's an odd number of values, and the median will be the average of two data values if there's an even number of values. Now you will see them in the examples. This is very easy. Now the median for the raw data, how do you find the median? You look at the raw data. If it is an odd numbers, how many values do you have? Odd number of values. So you arrange the data in order, and you find the number in the middle. This will be your median. But if you have even numbers, you can okay, arrange the data in order. Then the median is the average of the middle two values. Okay, we will see them in the examples. Now look at here. The number of books purchased by 9 customers is shown below, and find the median of this set of data. Now, the first thing you have to do is, the very important thing is to arrange the data. So if you want to find the median, you have to arrange the data. And after you arrange the data, you get this one now 2, 3, 4, 5, 4, 6, 6, 7, 8. And now we'll look at the number of the values here 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there are 9 numbers here. So this is how you find 9 numbers. So it's an odd number, odd. So what you can do here is you will find the middle number. So it means when you divide 9 by 2, you will get 4.5. So then round it up. The 5th number is the mode. So sorry, the median. So it will be 1, 2, 3, 4, 5. So this is the number. So if you check, this 5 here is dividing the data here into two equal groups. You see here this one and this one. So 5 is the median here. I mean, either you can use this equal parts definition, or you can directly say it's 9 numbers. This is odd, divide by 2, then round it up. Then this is the 5th number is your median. Or you can directly say 9. How can I make it like 4? 4, 1. So the middle, in the middle, this number here is the median. So here it uses the equal parts. Of course, you can do it this way. Let's look at this data here. The height of 14 players, basketball players, are given below, and we want to find the median of this data. The first thing in finding the median here is to arrange the data in order. This is very, very important. Don't forget this one. And then, okay, we ordered them. Okay, how many values are there? It says 14. Okay, let's make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 numbers in total. So if it is 14 numbers, it means we can divide them by 7 and 7 here, right? So then you count 1, 2, 3, 4, 5, 6, 7. Let's make one group. Sorry, this one, and the other 7 makes another group. Now you find these two numbers, just the middle numbers, and you take their average. So you add them, divide by 2, and this gives the median. So as you see, if we have even numbers, you can divide the data into two equal parts, 7, 7, and then you take these two middle numbers and you find the average of them, and it makes the median. Okay, let's see. Okay, so yeah. Now let's solve this problem. A company owns 14 cars to transport goods. Data below shows the average fuel consumption per liter at 100 kilometer driving distance of each car. So the data is given here, and we want to find the mean. The first thing we have to do is, arrange the data. Arrange the data in order. Yeah, let's do it. This first one is 6.7. And then 6.8. And 6.9. And 7. And then 7.5. Then 7.8. Then 8.2, 8.5, and 9, 9.3, 10, 10.1, 10.15, 10.2, and then 11. Okay, and we can check if something is missing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, 14 cars, good. Now we want to find the median here, so we will find the median. So 14 numbers, so we can divide them by 2, like we can make 7, 7 here. So 2 equal parts, 1, 2, 3, 4, 5, 6, 7. And this makes the first 7, the first half. And the second half is 7 also. And then we look at the middle numbers here. So the median will be now 8.2 plus 8.5 divided by 2, which is 2.35. We have another measure of central tendency, which is called the mid-range. Okay, the mid-range is the average of the lowest and the highest value of the data set. It's basically you find the lowest value and the highest value, and then you add them, divide by 2. This gives you the mid-range. Um, Now let's look at this example. Now a garage owner records the number of cars which visit his garage on 10 days. So the numbers are uh, listed here, and it says find the mid-range of this data. So you try to find the least value here, so which is 214, 204, and the biggest value is 300. Is it? Yeah, 314. So you add these two numbers and divide by 2, and then it will give you the mid-range, which is 259. So let's look at the properties of the measures of central tendency. Okay, the first one is the mean, the properties of the mean. It uses all the data values used in computing other statistics such as the variance. Yes, when calculating the variance, we use the mean. And it's unique. It means there are no two means, no two means, only one mean. So it means there's only one mean. So, sometimes in mode, for example, we have more than one mode. We might have, okay, it cannot be used with open-ended classes and affected by extremely high or low values called outliers. So this is important. This is also one other thing, because if you have 1, 2, 3, what's the mean here? The mean is 2, right? But when you put a very high value, then the mean becomes something like 25 point, maybe 27. Yeah, 26 point something, 26.5, something like this. So as you see here, if you put a very big number here, only just one number, which we call it outlier because it's extremely higher than the others. So this will change the mean, drastically. So this is affected by the extremely high or low values. And let's look at the properties of the median. And okay, let's look. Okay, gives the midpoint. The median gives just the middle data value. Let's not say the midpoint, but the middle value, middle data value, and used when it is necessary to find out whether the data values fall into upper half or lower half of the distribution. It can be used with an open-ended distribution. It's affected less by the mean, less than mean by extremely high or low values. Okay, let's compare it. 1, 2, 3. Okay, what is the median here? Median, it's 2, right? Because it's in the middle. So when you put here 2, 3, and 100, if you put one extremely high value, then the median will, okay, you divide it into two parts, so the middle numbers will be 2 and 3, and the median becomes 2.5. As you see, the extremely high or low values might not affect, the mean uh, that much. Now the properties of the mode and the properties of the mid-range. The properties of the mode is it's easier to determine, so it's most repeated value. It can be used for nominal data as well. It doesn't have to be a number, and not always unique and may not exist. So, uh, it, yeah, as you see, there might be two modes or no mode. And for the mid-range, it's easy to compute lowest plus highest divided by 2 gives the midpoint. Yes. Like, okay, I will not say the midpoint, the average of the maximum and the minimum, and affected by extremely high or low values in the data set. Yes, this is true. When you add a very, very big number, then it will change the mid-range of the data. Now, we look at the shapes of the distributions. Now, what I want, okay, first I want to remind you our procedure, what we learned so far. Raw data, for example, this is given like 1, 2, 2, 3, 3, 3, then 4, 4, let's say, and then 5, for example. This is your raw data. And we learned how to do frequency table. So it goes like 1 is repeated just once, and 2 repeated 2 times, and 3 repeated 3 times, and then 4 repeated 2 times, and 5 repeated 1 time. And then we do frequency graphs. So we learned how to do them, like you put the x's here, you put the frequencies here, and this might be also histogram. I mean, if it's the classes here. Anyway, just for the one, this is for ungrouped data, okay? So it's just 1 for 1. So this is 2 for 2, yeah, frequency, 3, repeated 3. Then we have 4 repeated twice, and then we have 5 repeated once. I mean, you can do them with the bar graphs, or you can do with the graphs. Anyway, just if you have more values here, you have more frequencies, you will get better data. I mean, a better graph. Now, this is, assume you have a frequency graph. It might be histograms, depending on, okay, forget this one now, depending on the data, the classes, you might have this type of thing. Now, after remembering this, we can talk about the shapes. So here we are talking about the shapes of the graphs of the distribution graphs of the data values. Now we have, they might have many shapes, and 3 most important shapes are positively skewed graphs or skewed to the right, symmetric graphs, and negatively skewed or skewed to the left graphs. Now, when we say positively skewed, we mean right skewed. And here it will have this characteristics here. So on the right side it will be skewed. So we say it's skewed to the right. And if you have such graph, something like this, or this is from the left side, the tail is on the left, so we say it's skewed to the left, so or left skewed. And another way of saying this one is this is negatively skewed. And if you have this type of distribution here, we call it normal or symmetric. Skewed, symmetric, no skewed. Okay. And now we will look at the characteristics here in terms of the mean, median, and mode. And we will try to see in which case we have this type of graph, in which case we have a symmetric graph, in which case we have a right graph. So in the next slide, we will see them in detail. Now, in a negatively skewed or left skewed distribution, the majority of the data values fall to the right of the mean, and the cluster at the upper end of the distribution with tail to the left. This is tail here, and tail and the left. So this is left skewed. And the general distribution, general ordering is this. So median is less than, the mean is less than median, and the median is less than the mode. So in this case, if you have this case, you can assume, or most likely your graph will look like this, the frequency graph. And in the symmetric distribution, the data values are evenly distributed on both sides of the mean. So in this case, we will have such graph, and this type of graph we call it sometimes symmetric graph or symmetric distribution. And here the characteristic is mean, median, and the mode. They're same. And positively skewed or right skewed distribution, the majority of the data values fall to the left of the mean and cluster at the lower end of the distribution. And here is what we see on the graph. So from the right side, it's skewed, right skewed. And the order of the mode, median, and mean is given this way. So the mode will be less than the median, and the median will be less than the mean. And if you see this type of ordering, you can assume most likely you will get a graph right skewed. By the way, these orderings, theoretically not 100% true, and the relation between these orderings and the graphs, because there's always a possibility that the orderings might happen this way, but the graphs might like the other way. But we are excluding these cases because this what happens in the most cases. So for this reason, if we give you this ordering, you should tell us, it's most likely it's left skewed, and if this is the case, it's most likely symmetric data. And if it is the case that if this is the case, you tell us the distribution is right skewed. Now let's look at this question here, this example. From the distribution below, find the mean and the median and the mode. So the first thing you have to notice is here, this is left skewed. So if it is left skewed, then we have an ordering. Always the top one always goes to the mode. Mode is the high repeated, the most repeated one, the most frequent. So it means it will have the highest frequency. And now then we will have the median here, and the mean comes here because it's left skewed. So for this reason, we will have mode bigger than median, and the median is bigger than the mean. Also, you can say this one negatively skewed. It's left skewed or negatively skewed. They're same. Okay, let's look at the worksheet problems. Question 1. If the mean of 12 values is 4.8, find the sum of the values. So let's remember the definition of the mean. So it's just the sum of all values divided by the number of the values. So this is the sum of the values, all values in the data divided by the number of the values. Now in this question it says the mean of 12 numbers is so here 12 is equal to 4.8. So 4.8 is the mean, and we have 12 numbers, and it's asking the sum of the values. This is the sum of the values. So how can you get this? You multiply these two, and you get the sum of the values. The sum of the values will be equal to then 12 times 4.8, and which is equal to 47.6. For the following distribution, what is the correct arrangement for the mean, median, and the mode from left to right? So from left to right means here in the left side in the real axis, left means small and the right means anything on the right is bigger. So it means from smallest to biggest. So you have to list them this way. Okay, now how can we know the order of them? So it gives this distribution. So you'll look at this distribution, that this distribution is right skewed. So in a right skewed distribution, you have, if you remember it, so we have the mode first, and then there comes the median, and then comes the other one, which is mean. So if it is right skewed, we have this type of ordering. So it will be mode, median, and the mean. So this is be from smallest to biggest. And this is the smallest one now, mode, and the biggest one is the mean. In this distribution, what kind of mode do we have? So to see this one, okay, first order them. So let's write them in order. So 0, 5, because we have to look at the repetitions here. 5. Okay, I forgot 3 here. 3. This is 3, 0, 3, 5, 5. And then 6, 8, 8. So what is 8? This is 9, and then 16, and then 24, 25, and 45. So, okay, mod means the most repeated element or the value. So here 5 is repeated twice, and then 8 is twice, repeated twice. So the modes are 5 and 8, and there are no repetitions, no other repetitions. So the modes are 5 and 8, so the distribution is bimodal. So bimodal means has 2 modes. That will be B. Now find the final grade using the following table. Okay, first assume we don't have these percentages here because they're out of 100. So I think this is given to you to say they're out of 100. And final grade. Okay, these are the weights. So it's asking the weighted mean. Okay, weighted mean of the scores. Now we know the formula for the weighted mean. We multiply weights with the data values divided by the sum of the weights. So the weight times the scores, so we multiply them. You multiply 75 times 0.2. It's and here 80 times 0.2 or 0.2 times 83. Okay, this just multiply. You multiply them and 0.25 times 87. You add all of them, and you add these. When you add these, the sum of W's here, it will be equal to just 1. So you can check. It's 35, and here 65, so it makes 1. So here this is just 1. Now this sum here is equal to 83.15. So the answer will be 83.15, which is, yeah, which will be 83.15. So the answer will be A. Okay, if the mean, median, if the mean is 25, median is 30, and standard deviation is 15, the distribution will be, okay, negatively skewed, positively skewed, or symmetric, or what? Now, to say, we have um, three orderings, like two typical ordering. If the mode is less than the median, which is less than the mean, we typically have a distribution, a right skewed distribution, right skewed distribution. But if we have the mode bigger than median, which is bigger than the mean, we have a left skewed distribution. And if they're equal to each other, so we have symmetric, most likely a symmetric distribution. These are the cases. But here, the mean, okay, it's less than the mean is less than the median, but we have to have some information about the mode. So what can you say about the mode here? So standard deviation, nothing to do with the mode. So the distribution, we cannot say this happened or this happened or this happened. So it cannot be identified. Now, which statement is true about the shape below? The distribution is I and 2i. So as you see here, we have something on the left here. It's left skewed. So in the left side, it's pushed down, and here this one is on the right side. It's pushed down, so it's right skewed. So we can say left skewed means also negatively skewed. The other saying is this, I mean, synonym, let's say. And this right skewed means positively skewed. So in this case, I is left skewed or negatively skewed, and 2i is right skewed or positively skewed. When you look at the choices here, distribution I is negatively skewed, distribution 2i is positively skewed. Okay, this is what we said. Find the mean for the following distribution. Okay, these are the marks obtained by the students, and this is the number of students who obtained grade. Now it's like this is the frequency, so how many times this score repeated in the data set, and these are like the x values. So how can you find the mean here? If it's an ungrouped data, so you have to have this mean f times x divided by the number of the frequencies. Now just you multiply the x times f here, or f times x. Okay, it doesn't matter f times or x or x times f. So this makes 20. So you multiply 33 and 96 and 42 and then 60, and you add them. When you add them, you will get this sum, and which is equal to 251, and the sum of the frequencies here is okay, if you add them you will get this is 20. So 251 divided by 20, which is 12.55. So we have C. That's the correct answer. The following frequency distribution represents the amount of sugar for in milligram per liter for a sample of bottled drinks. And we have a grouped data here. A group data. This is a group data because we are given the classes and the frequencies. And we want to find the mean, the model class, and the mode. So for the group data, the mean formula is this. So it's just the frequency times the midpoints of the classes and their sums, and then divided by the sum of the frequencies. So we have to find the midpoints. Okay, the midpoints are okay. The midpoints of the class limit. So it will be 3 and 7. 7 plus 3 divided by 2, which is 5. So midpoint will be 5. And then in the same way you can do it for this one, 10. So this is 15. This is 20, and this is 25 and 30. Then we have to find the products, the frequency times the midpoint. 3 times 5, 15. 5 times 10, 50. And 2 times 15, 30. And then 8 times 20, 160. And then 14 times 25, which is 350. Then 8 times 3, 800, and 8 times 30, it will be 240. And then when you add them, you will get, if you add all of them, you will get the sum as for 845, and you will get the sum of the frequencies as 40 here when you add them. So the mean will be 845 divided by 40, which is about 21 point, okay, this exactly, it's 21.125. And the model class, if you remember, the model class is the class that has the highest frequency. In this case, the highest frequency is 14, so the model class will be 23 to 27. And when it comes to the mode is the midpoint of the model class, which is 23 plus 27 over 2, which is 25. For the following data, find the mean, mode, median, and the mid-range. For the mean, we just add all the values divided by the number of the values. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 numbers. And we add all of them, 8 plus 9 plus, and it goes up to 31. This will be, you can calculate, you can try yourself. So 19.5. Now when it comes to mode, we have to check the most repeated ones. So is there any most repeated value? 8 repeated ones, 9, 10. Okay, no repetition at all. So no repetition of numbers, so there's no mode here. There is no mode in this data. And then median, so for the median we have 10 values here, 10. So you have to split them into 2 equal parts, like 5 and 5. Since this is even, you can divide them by 5 and 5. And these 2 numbers here in the middle will make the median. So their average will make the median. So it will be 19 plus 20 over 2, which is 19.5. Now when it comes to mid-range, the mid-range is, the highest plus lowest divided by 2. So it will be 8 plus 31 divided by 2, which is 19.5. So in this data, we got the mean, mode, median, and the mid-range, all of them same. The mode, sorry, there's no mode, but the rest is same.